In this video we're going to look at the non-inverting amplifier configuration. So if we look at the non-inverting amplifier circuit that we have here, we can see that we still have the feedback resistor R2 going from the output to the inverting input. So that's the same as with the inverting configuration, but we now have our R1 resistor going directly to ground, whereas our non-inverting input has our input signal V1. So this is the difference in the circuit setup relative to the inverting configuration. So just as with the inverting amp setup, we want to be able to work out how this configuration will affect the output characteristics and the gain of our amplifier. And once again, we can do this through simple circuit analysis in a few discrete steps. So step 1, here we're going to recognize that the difference in voltage between our inverting and non-inverting inputs, let's call that VID, is equal to 0. So here we have V2, V1, and the difference between these is VID. So we showed this in the inverting amplifier video, that if we assume our ideal amplifier with an open loop gain equal to infinity, then that will force our inputs to be matched, and therefore the difference, VID, is equal to 0. For step 2, it therefore follows that our voltage at V1 is equal to our input voltage Vin. This one here is equal to this one here. Now for step 3, here we simply calculate the input current as before, so that's I1, but we note that current's going to be flowing into ground, so it's going from right to left, unlike with the inverting configuration where we were going from left to right. So in that case, the current is going to be V1 minus 0 over R1, and we know that V1 actually is equal to Vin, so that would be equal to Vin over R1. Now for steps 4 and 5, as before, we simply recognize that there can be no current going into the terminals of the op-amp due to the infinite input impedance. So I minus equals 0, leading us to step 5, which will state that I2 must equal I1 due to step 4. So now we have I2 equal to I1, and we know that that equals Vin over R1. So for the final step, step 6, we simply calculate our output voltage. So that is the voltage on the left side of the resistor there, which is V1, and we've already shown that that is equal to Vin. And we're going to add to that the voltage dropped across the resistor R2, whereas before in the inverting configuration we would have subtracted that, but because the current in this case is flowing from right to left, it will add. So that will be Vn plus R2 I2. So we can rewrite that as Vn plus Vn over R1 times R2. That's just substituting in what we earlier calculated for I2 in step 5. And we can simplify that equation by putting the Vn outside the brackets, and we have Vn times 1 plus R2 over R1. So that's our transfer function, and as we know, our gain is equal to V out over V in, which therefore equals 1 plus R2 over R1. And that's the gain of the non-inverting amplifier configuration. So of course the key thing to note here is that with this configuration, your gain, which can still be controlled by simple selection of the resistor values, will be a positive value. Whereas with the inverting amplifier configuration, the gain is always a negative value. That concludes our analysis of the non-inverting amplifier configuration.